Hello and welcome back to Factorial. My name is Apex Nasty. In today's video, we're going to be building this that you see in front of you. So what is this? Well, obviously it's a utility science build that makes 240 science per second. Unobviously, why are we building this today? Well, one, I'm about to host a competition for utility science, and the deadline for submitting stuff is next week. So tune into my Discord if you are interested in participating at all. There's people that already are submitting designs. So the main goal of this video is to go and create a baseline design. Why do we have a baseline? Well, every single time I go and create one of these competitions, I want a design that we can use to kind of get a sense of what a relatively good design is, but how much more of an improvement we can make beyond a typical design that has no clocking and just uses some basic concepts, so nothing too fancy. So we're going to be building this thing here today, and then I'm going to be making that baseline for that. So the whole goal is hopefully that you can, by the end of this video, get an idea of all the complexities that go into utility science if you haven't done it at a megabase scale. And then the second thing is I'll walk you through a little bit my thought process. I've already recorded the creation of this, so without further ado, let's get into it, and I'll see you in the rest of the video. All right, so originally when I was going and creating this science, or trying to go and create this video for this creation of the science, I originally set a goal of trying to go and create speed run. So I was trying to get it in under 30 minutes because it's usually has been whenever I go and create a new baseline build, I give myself 30 minutes. I never record myself doing it, but I just say, trust me, bro. I've done this in under 30 minutes. So a lot you're going to see here is muscle memory from all those different attempts. I'm giving up. What I'm going to do for this video is I'm going to strictly just try to create a design and just do it in a very chilled manner. We'll cut out the stuff that I don't find interesting afterwards in editing, and we'll go from there. So first off, what are we going to need? We're going to be making 120 science per second. That's the idea that we're going to be making on one half, and then we'll mirror that on the other half, and then that'll be the 240 fully. So we'll think about things in terms of one half of this. So what we're going to have is we're going to have two inputs, right? We're going to have one input that's going to feed processing units and flying robot frames, or processing units and LDS. For clocking, it's going to be easier if LDS is on its own, but it doesn't really matter. We're just going to choose these three ingredients, and because the inserters are going to swing to balance them out, we'll just have processing units and flying robot frames. We'll assume that's going to be the case on one side and low density structures on the other. Now for speed, 12 beacons, although I absolutely hate the way that this looks. I'm not a big fan of 12 beacon designs. It's super easy though to go and create one. So that's what we're going to do today. We're just going to do a 12 beacon design. The reason why it's kind of irrelevant is because 6 copies of this setup here, so these module, will get you to 118 per second. So it's just shy of the 120 that you need. So we need one more, but then that's way overshooting the amount. So we could go and say we're just going to do a 10 beacon design, and you could go and see that here. So maybe we'll just do that, and that way we're still over the 120, but we don't need excess beacons. And in practice, if you're going to have that many beacons, having 2 extra for the final machine to just barely run is probably not worth it. And the reason I say that, and without testing this very specific design out, I'm saying that it's not going to be worth it because the extra beacons are going to take up 100 at every 120 ticks. They're going to do an entity update where they go and they check their distribution efficiency and their effect on beacons. So if you have low power, you have brownouts, different things like that, it kind of is calculating that every 120 ticks or every 2 seconds. So for that reason, having these extra beacons here is not going to really help us, and we can eliminate then in this case 2. And then what is there going to be? It's a number of machines. So 14 beacons total that we could go and remove. So that's probably worth it. And it's not going to hurt us at all because we are very easily in the 120 per second range. So let's go and connect this up. We're just going to have this come out here, go down here like this. This comes over here and then over and then out. And then I'm using editor extensions. It makes it super easy to go and create stacked copies of everything. And let's just go and grab all the inputs, real simple. One thing I like to do is I like to have constant combinators. The reason I do this is if you go into settings and you go in the interface, make sure that you have an alt mode, you show the combinator settings in alt mode. What that allows you to do is now we can go and specify the inputs we're going to have here. So let's just choose, the different inputs. We have low density structures, is going to be 1. And then over here, we can press Q to grab the flying robot frame from here. And then we'll also grab the processing units, press Q, hold it, grab it. All right, so that's useful because now we can just flip this over and bring that up there. We'll bring this in here. And then we can shift right click and left click over and over and over again to get all the inputs in. So that's why I like editor extensions so much, because it's so easy to go and copy and bring all your items in that way. So let's just go and have this come out here, and we'll just be able to monitor then if we're actually producing enough science. Seems like we are. So sometimes this can be a little bit of a misnomer, because it might look like you have the fully stacked belt. What you can do is you can press F5, go in here into the debug menu, and you can type in gaps, so show transport line gaps. That's that little white stuff that you're seeing here, these little gaps. That helps you visualize it. So if we had any gaps here, for example, if I remove this one assembler, you're eventually going to start seeing some gaps form. And then you can visually see it, but sometimes it's really hard to tell, especially on things like space science. So in this particular case, those little white gaps, those lines, the debug settings will let you know, hey, you're not producing enough. But we know we are because we did the math already, and we use what is it called? The rate calculator tool. So cool. We got the head module designed. That was pretty easy. We'll go back and we'll add power later. That's not really a big deal. So what we'll do is we'll do that at the very end. So here I just have on the surface global electric network turned on. That way the whole entire surface has power the moment I just slap an accumulator on there. So you just grab one of these accumulators, it's on the surface. Now the whole surface is powered and we can deal with power later. So in the speed runs that I was doing, I had these things just as a quick something so that I can go and reference it. So what we're going to do is I'll just keep copying things from here and we'll keep building things out. So the next portion that I want to go and solve is I want to go and design this flying robot frame. I'm going to be calling this FRF for short, just because I've been used to kind of the speedrun stuff. So I've done this multiple times already for several designs. So I kind of have a decent idea of what I want to do with this because I've kind of pre-planned this out. But what are the ratios that we're going to need? So we can look at this. Roughly, this is 120 per second. So then that means we're going to need 40 processing units, 20 flying robot frames, and 60 LDS per second. So let's just keep those in our head. 60, 40, 20. Very, very simple in terms of the ratios of what we're going to need. So we're going to design for 20 flying robot frames per second per side, right? So if we look at one of these, this is going to get us over 5 per second, which is kind of nice because then 4 of these copies are going to make us enough. If I delete this, 7 beacons is enough to get us the actual production output that we're going to have and still be over 5. 6 beacons is not going to be enough. So let's just do 8. And the reason I'm going to do 8 is because it's so easy to just copy this multiple times. And what we're going to do then is we're going to kind of imagine the inputs that we're going to need, right? So let's just do this very simply, right? We're going to have an input there, going to have an input. So one of the inputs that we're going to need, because we're going to need 4 things, is we're going to need steel plates, batteries, electronic circuits, and electronic engine units. I don't care what they are. We can decide that later as the rest of the build kind of comes about. And then something else that we're going to need is we're going to need to go and output these items. So the easiest way we could do that is we could do something like this, and then just drag this all the way through here, and then down, down, and then etc. So we now have a template that we can use to just bring stuff out. This is now tileable, right? So we just need to copy it one more time. And now we have all 20 per second that we need. Cool. So that's good. Let's go and trim the stuff we don't need. This is in a decent spot. Let's just copy this. Let's flip it. And now we have everything that we're going to need. Now, one thing I haven't mentioned yet, because I've kind of glossed over this, you see how this format looks the same and these beacons happen to start lining up? That's something that I'm wanting to do. So actually, the way I'm going to lay out this entire thing is I'm going to keep this as my standard template. So this is going to be the frame of which I build everything in this entire build in. And the reason for that is so that it's easy for me to tile this build. So more strictly speaking, if I take this, I want to be able to do that. That is a goal for this design. I try to always do that. So when I design stuff, I go and I say, okay, I'll build a science module in the way that I would like to lay it out. And then I say, whatever the beacon placement looks like, that is going to be my design that I'm going to have to be forced into for the entire rest of the build. So if I made this slightly more compact, which we probably could by squeezing this in a little bit more, then we could have an even more narrow build. Given the fact that we're going to be using foundries for this, I want to give myself some extra space. So let's just use this as our template going forward. Cool. So that's going to be our template. We'll keep that up there. All right. So now we've got the flying robot frame kind of decently laid out in the way that we want it to look. So next we're going to have to figure out how to go and create the engine units. So that's the next ingredient. So I'm going to go from the most complex down to the simplest, right? Steel plate is super simple. That's just a foundry onto a belt. Bring it out. Same with batteries. 2 inputs that we're going to need and a little bit of sulfuric acid. Who cares? Simple. So what we're going to do is let's start with electric engine units. So let's go and grab that recipe that's in here. So let's go and grab the electric engine units. Conveniently, it's right next to it. So I have to go and check this, grab that, boom, done. All right, yeah, we're going to have lubricant, but who cares? It's not that big of a deal. So let's just grab our whole template here and let's start imagining this as our design. So I'm going to want to butt it up as close as I possibly can to this. Now, this is actually going to impact these because now these are going to be faster than we actually need. We could remove a couple beacons in here, like one of them, just so it's not too high, but we're not clocking the build today. If we were clocking it, I'd want them all to have the exact same crafting speed. So on the little popover menu that shows up on the right, it's the very second or the third item from the top where it says crafting speed is 56.5. I'd want those to be exactly the same so that if I set up a clock, all the inputs and outputs are all going to happen at the same time, so everything can be synchronized. It makes one clock easy for this whole thing. For this build, I don't really care, so I'm just going to go ahead and just slap the template down. And maybe we can remove some. But if I look at this just like initially, so if I butt this up as close as I possibly can up here, or I'm going to start with up here because this is just easier for me to think about. Let's just see what happens if I slap some beacons in here. Well, this is 10.5 per second. So just without changing anything. And we could put another one in here maybe, and we can get to 11 and then delete that. And that would get us to 10. 10's magical because the items that we're going to need is 20 per second. And at ratio, because of the 100% productivity that's in here, it's a 1-to-1 normally, but it's really half the amount that we're going to need. So you can see that here is like, imagine this is 20, then this down here is just going to be 10, right? So as long as we're over 10, let's see if we remove one beacon. Nope, that's less than 10, so that's 9. So cool. That's all we really need. Don't care about the fluids. We can figure that out later. We'll just think about this like, what are the items we're going to need? Well, we have electronic circuits here. And conveniently, this also needs electronic circuits. So let's just drag that out. So that means we're going to have at least an input here that can do this. So we can slap that there. I don't know. We can put it here too. Spacing wise, I need to think about kind of getting an output here. So maybe we move this slightly over. Beacon still touch, and then we can get an output somewhere. So I don't know. We'll put this here. See where we go from there. And then I'm going to put things as far away as possible in terms of the inputs so that it's easier for me to do stuff like bring this out, right? So let's just plan ahead for that. Okay, so what's the next thing that we're going to want? Well, we're going to want engine units. So let's grab, I think I have that already. Great. I'm just going to directly insert this because I know in theory, yes, I could do something where I double insert into both of them. I don't think it's going to matter. It's just the number of transfers is the only thing that I'm going to be trying to optimize for here. So let's say we do something like this. We get the inserter to go from here. And one convenient thing is I know that we're going to need steel for flying robot frames anyway. So that actually solidifies exactly what we're going to put on this belt. This belt purely is going to be here. Let's grab a constant combinator to specify it. It's going to be green circuits and it's going to be steel plates. So that's definitely what we're going to want here. Okay, cool. Let's go grab infinity loader, shift right click, shift left click. Cool. There come those inputs, and then this gets both of them, and everything's fed. That makes total sense. That makes it really easy. And then steel is just a common part that we're going to be bringing down. Now, one thing that I do know is that the only thing I'm going to be needing gears and pipes for is literally right here. So as much as possible, I'm going to try to do some direct insertion, time permitting. And I think, I don't know, we can just do something like this for now. So, and then just pretend this comes out, and let's just get like some fluid input here just so we can specify things. And as I go, I keep marking things so that it's easier for me to just, in the end, go and wire everything up. So shift right click, shift left click. Did it not do it? Oh, yeah, that's interesting. So we actually need to put it, it seems like in that first slot, and that's the only thing where shift right click and left click will work. Okay, for fluids. Okay, good to know. So, all right. So this allows me to insert here and insert here. So we have this input, this input. I'm going to have to do this on the bottom. Don't really like this. So maybe we do something like this. I'll show you what I mean here in a second. And then we do something like this, and just bring this, way over here somewhere. Because I'm going to have to mirror this. This has to come out. So I'm going to need something like this actually. And then come over here. I don't need fluids later, so we could just leave it there and call it a day. And then this would come out. Now, we'd have this whole thing on the bottom, just like this. Fantastic. And then let's think briefly about the fluids. So I'm going to want probably something like this and then coming out like here. I don't know. We can put that there. Specify the lubricant and put that in here. And then let's just grab a fluid output. There you go. So we could run lubricant again down here, but I don't want to bring it all the way through the rest of the build that's going to be on the left. So we could try something like this, and then it doesn't quite get me where I want. Let's try moving these in a little bit and then extending this, and then copy this. Oh, perfect. That works out exactly. All right, so we have an output. I'm going to kind of want to feed this in here. And what's the other item? Well, I'm going to need batteries. I'm trying to think about beacon placement. I'm going to flip this around immediately because this can benefit from all these beacons that are over here on the right. And this doesn't need beacons at all. We could add beacons later, but we don't need them. Because we don't have any beacons touching this. This is way too slow for the output that we're going to need here. It just barely can crank by, but we're like, there's no point. If I don't want to add extra beacons for one building if we don't need it, but if there's beacons are already there that we're going to need for producing the electronic engine units, then we might as well just use them for the gears. So I think that's good. Let's see. Next here, is this enough? Yep, we're positive, so that's fine. Okay, so we actually have everything. We're already outputting the electronic engine units, so that's pretty solid. Right, where was I? Right, batteries. So batteries are going to come in here, and then we're going to need electronic engine units. So actually, ideally, this could come in like this, and I happen to know that this is the pipeline, or the extent of the the turbo undergrounds is these two here. So that actually works out pretty nicely. And then the spacing here works out pretty nicely too. So cool. We can bring this in and bring that out like that probably. And then bring this in and out. And then we just have to have batteries on the inside here. So we'll grab a battery and we'll copy that. We'll bring that in just for now. Flip it. Bring that in. Yeah, there we go. So now we got batteries coming in. We've got all the ingredients, and this is coming out on there. Yay! Fantastic. Cool. So what is this down? Oh, yeah, I forgot to connect that up. I was going to say something's wrong here because this is stacking up faster. So good. So that looks pretty decent. Let's kind of think about how we're going to marry or do the wedding, so to speak. In the auto manufacturing industry, there's a wedding that is performed when you bring in the main assembly, like when you're doing like bringing the engine block into the car. That's called the wedding. So we're gonna kind of do that too. And funny enough, we're making engines and stuff, so it's kind of fitting. Okay, so I don't need this anymore after this point, so we can trim that. This is gonna have to come in. All right, conveniently, let's just delete this. Let's keep these as a reference just so we have them later. And then let's think about how we connect all this up. So let's bring this all the way in here. And yeah, we don't need this. We can trim that. We don't really need undergrounds here. And what we could do is we could just bring this in and then potentially just bring this up and over like that. So I kind of like that. And I think we're in a good spot. Now I'm going to do a completely unnecessary thing here. I'm going to go and flip this onto the other side. And this is, I don't even know if this is better for UPS, but I'm going to do this anyway. The idea that I have is that here we can be on the inside lane, and the inside lane is what these inserters are going to prefer. So I mean, if I can just easily do it, like, why not? So let's just delete this, delete this, delete this, delete this. And then let's just copy this whole thing and flip it, bring it in. Cool. Delete all this and let it run again. So that's going to allow us to bring the items in, and we could run either blue circuits this way through this whole build, which is pretty good. So we could do something like this and continue it on and have blue circuits on the inside, or we can have blue and LDS go together, because what we can do here, I'm thinking, is we'll copy this, bring this over, and then what we can do is something like this maybe, and then we bring the other inputs in here. I think for simplicity's sake, routing all the way through the build, because I'm going to want LDS to be the first thing, so I don't have to deal with coal getting routed through the whole entire build. I'm going to say, I'm going to make an audible, I'm going to call an audible, and we're going to say we're going to do this as the inputs. So I'll go and specify this, and let's just bring this as far back as we can, and then let's do the same thing up here. Yeah. So this will come in like this. We'll bring this in here like the same way, and we'll just mirror it. This is extra materials that we don't need, but who cares? That makes it super simple to route this in. So yeah, I like that. All right, so this comes up in, done. So that should be all the inputs, and we should have enough production capacity. Let's just go and speed this up, and let's see where we're at. So we got half the build doing well. Oh, yep, we're missing this here. There we go. Yeah, that's 240. F5, go check real quick. All right, happy man. Cool. So that is now the first part of what we're going to need. Let's grab our template. And the next thing I'm going to move on to is I'm going to want to do blue circuits, and I'm going to have to make LDS. So I think I'm going to start with LDS because I want to make a layout that's going to have plastic for this. Now, I've previously designed something like this and in some of the speed runs that I've done, so I'm going to be working a little bit off muscle memory here. So I'll kind of show this build. I really like this. What it is it's kind of, you have these pipes that come around here and you do the same thing on this side. And then we flip this over. And what's nice about this is then you can very easily connect everything up. Let's even move it back one and then do the same thing up here. Now you have an easy interface for connecting the fluids. And then what I'm going to be running is some kind of a fluid bus like this. Now, I'm just, for simplicity's sake, I'm going to move this plastic over here. That's going to make it a little bit easier. Let's move that over, something like this, to give ourselves some space. And then we'll have this maybe up here, and then we'll copy this, and we'll bring it all the way down, right? So what this allows us to do is just have an input here to connect this. Now, I'm going to want this to be, I'm going to specify this in a different way. We're going to move this slightly over. And the reason is so that I can much more easily explain what the inputs are going to be for each thing that I'm bringing in. So we'll move this even further over, something like that. So what I like to do is I like to always mark every single input that's going to come in so that whenever someone uses a build, they are really clear on what they need to connect. So that way they know, hey, this input is always going to have to be petroleum gas, like that, right? So cool. And then what we can do as well is we can connect this up. Let's move this further up here, just way up here, just so that it's super easy to connect everything. So it's something like this. So now we can bring this in. And then what we can do is underneath here, we can be a little bit more sneaky. And we can do this to bring this over here. Yeah, that's great. And spacing wise, that works out pretty nice. We can do this, and then let's mark this as molten iron. Great. And then we'll grab this up here and we'll mark this as the molten copper. Again, I'm just pressing Q to quickly select the items that I want. So this is convenient because now this is, if we look at our kind of standard template, this is the pattern that we're going for, and this can fit easily in the number of beacons we want in here. Conveniently, this almost gets us to 60. And if you have a 7 beacon layout with all legendary, you get exactly 60 per second, which is pretty nice. So I'm going to need some kind of an output here that's going to do this. So let's just have something. Let's call it good enough. Let's bring it out and do something like this. And then we'll do the same thing and bring it out. Then we got really simply a little simple LDS setup. And then I think this is good. One thing I'm going to want to have is I'm going to want to have plastic out. So I'm going to want to design something where I can get the plastic out for red circuits later. So this could work. We could have something like this, and we'll see if that's good. For now, let's just call that good enough, and we'll just do this. Just to kind of mark that, hey, we're going to use this plastic later. And I think this is 220 per second, and that's plenty for this. So I'm not going to go and add any more speed beacons. Cool. So 60, 60. Yep. All right, so LDS is done. So that's really simple. And we'll just extend this just so that we have the same pattern. Am I missing any markings? Input, input, input. Nope, nope, nope. Everything looks good. Cool. All right, now we go to the most complicated and head-scratching thing of all time, which is getting blue circuits to work. And I'm kind of imagining that I'm gonna have to do this multiple times to get this to work. But we'll see. All right, first off, let's just see how many beacons we're going to need. Now, if you remember, the ratios were 60, 40, 20. So 60 LDS, 40 blue circuits, and 20 of these. So we need 40 of these. So how many beacons do we need to get to 40? 4 beacons almost gets you there, but 5 gets you over. And this is also assuming, and all these builds that I'm creating are all assuming you have max productivity researched. So if you're doing this is like nth degree mega basing stuff. So I'm not going to worry myself about having lower prod levels. It's just you have everything maxed out. So the main thing that we're talking about here, level 30 research, 31 available, is when you get to the magical 300% productivity bonus, and then you can do all speed beacons in here. So if you didn't have that and you have let's say one lower, you won't be able to get there with just 5 beacons. So you can't go and take one of these designs and just say, oh, okay, I'll account for the limited productivity I have. No. So it actually getting that stack allows you to hit certain breakpoints. So it's really, really important to hit those numbers before you use any of the designs you're going to see in this video today. So that's a little bit of a disclaimer there. So then what we'll do is, let's see here. This is where things are going to get a little complicated, right? So let's just grab all the items we're going to need. Ideally, this is where every single time I was doing a speed run, I would get to this point and then everything would break down because I'm artificially constraining myself to this configuration here. And so it really limits what you can do because it's actually really simple to go and create a relatively like a working design. So if you have a little bit more space and can give yourself some more flexibility, because I'm so strictly keeping this rule for myself, that's why we're having these issues. So, okay, so let's see. What I'm going to do is I'm going to do a couple things. So inputs, because we're doing targeting 40 per second, we're going to need 200 plastic, or it's 200 electronic circuits per second. So definitely direct inserting here makes the most sense. What I need to think about this being mirrorable, so I can't really have this here because, right, if I paste this and flip it, that's not going to work. So I need the space, so let's move this up here. That allows me to input there, and I just need one input. That's completely fine. So that covers what I want. Now, I could do this direct insertion, and then this layout kind of works, I think. And then we could even imagine having another beacon here, but we can't do that because we're going to need these. So I'm going to need this, potentially this. So let's grab this. There's a couple ways we could go about it. We can say we're going to do this here. Oh, okay. So a thing that I'm noticing that I kind of would like to keep is if I can, along this entire length here, I'd like to keep this input all the way through consistent. And ideally, I need to remember that I also need to bring in some space for lubricant and sulfuric acid needs to pass through. I'm going to kind of constrain myself to that. Now, conveniently, what we can do is we can do something like this. If we do this and I look at this line here, I would need an input there. So I'm going to kind of force myself to be constrained to that. So a place that I have to remember with tiling this is this right here is like a no man's land. You cannot cross this because the moment that you, let's say I delete this here and I place this up here like this, if I go to like tile this right now, it won't work because they're going to collide. So I can't do that. So given that that's the case, I may just for simplicity's sake move this up. I can move that in there and do the same thing down here. As much as I don't like that, because I'm going to have to, I've already made this conscious decision. I'm going to bell green circuits here. So I could just pick that up and I'm going to bell plastic. So I could just pick both, but that allows me to do dead man, no man's land here. So that's fine. Okay, so let's see, this is still over 40, so that's good, that's good. And then connecting with this concept, this goes all the way across here, and that can connect in. So now I need beacons on this, so that's another constraint. So actually we can do this, and then this is way over we don't even need these beacons here. We could go and get rid of those. And we could bring this in all the way here, just so that, because we're gonna need, I have to kind of think about having beacons around this, because this is gonna need to be 20 per second. So this is still way overkill. We only need 40, but now this is 20 per second, and 20 per second is going to get us to 40. So of this. So that's good because of the 3x prod multiplier. So then, all right. So then the next thing is, let's kind of think through this. The easiest thing to think about is, okay, I just need this, right? So we could do 1, 2, 3, 4, and do 1, 2, 3, 4. So that gets us where we want, actually. So that's pretty decent. The only thing that is kind of annoying with this build is that I now need some sort of I need to bring copper in right there, so it's not terrible. Another thing that I want to leave open is kind of like an extra step in productivity. This is not really useful because this is better for UPS as one less transfer and it's just raw fluid input. And kind of nicely too is I could do this. I could bring this in and then connect that up right there. Boom. And we could do the same thing, but then I have iron here, so that's not exactly what I want. Because like the iron also needs to flow and come up here. Kind of limited by what I can do. Let's just pretend that we have all this stuff here figured out. So we do something like this. We could bring maybe this in here, something like that, and then up, and then copper comes in. So we're good. We could do this. Now we have copper solved. The next thing I'm going to need is an input here for green circuits and for plastic. But okay, here's a problem. I want to reuse this. So, all right, let's imagine this. This is gonna be 200 per second. how much of the green circuits am I going to need? This is going to be 10 per second plus, so we need 40 extra. So 40 extra plus 200. So this is technically enough. So we can just use the same building. So we could have this output, but then I'm going to need this to pick it up. And I'd like it to continue on, ideally, if I can, up here. That would be really, really nice. Now, that might be hard to fit that in. Now, with no man's land here, we can bring this up 1 and not care. Let's see how far back we can bring this beacon and still be hitting that. So that's good. Okay, so hold on. This actually might work out. So we can bring something up here, bring something up here, and then we can keep on going that way with green. Yeah, that works. So if we do this, and then let's just simulate, for now, something like this, just so that I've got copper and kind of can imagine this. And I need inputs. There we go. So now this can pick up green circuits. So we'll need plastic there. That will look super ugly, but we could make that happen. Something like that. And that's on the wrong side of the belt. Okay, an easy thing we could do to fix this is flip this. You might be wondering, why are you doing it this way? But it serves 2 purposes. One, it's going to allow us to get on the opposite side of the belt. Plus, it's already going to pre-align us for what we need here. So we can actually just very simply bring this all the way in here and then over and out. Now, I don't want plastic continuing on the belt like this. So, all right, this is cursed, but you could just do that. And then only the green circuits keep going. And then there's no plastic on that side. You can kind of see that here. So the plastic stays there, and then... All right, so I'll have to flip this orientation. Big whoop. So flip that just to mark that. But now the green circuit's going to be inside, and then I can line it up later. Not a big deal. All right. And oh, I need to also... Yeah, I'm glad I'm thinking about this. I need to keep in mind that I'm also going to need to output this somewhere. And I need to get LDS to come over. So... And I need to bring copper further as well, because I'm going to need to make a plastic build. All right, quickly, plastic. So plastic here, something like this. Not plastic, sorry. Batteries. Something like this. Like, let's just keep it as stupid simple as possible. I want to keep that same bus layout that we had. Let's do this. Let's copy that. That's kind of the idea. We're going to want to bring this in. I'm one off tile-wise. Bring this in here. I don't know. Do something like this. Flip this around. Bring this in here, something like that. And then cool. Yeah, that works. And then this would come in like that. And that's all. All right. I have done this quite a bit, so I know the ratios of what I'm going to need. We're going to need 20 per second of batteries. So with that being said, we are very, very close. We need 40 total, and we need something that can kind of output. Yeah, it doesn't have to be amazing or special. So just something that brings the batteries out. And let's think about this. I said that we're going to be on the inside lane going forward. So this looks like this. That's the idea. So how do we get it on the inside lane? It's this, right? Yeah. And then that is on the outside and then goes here. All right, that's perfect. That's going to be the direction we're going to go. And then that allows us to put another beacon there, and then we're over 40. Yay. All right, great. We'll do something like this, something like that. That gives us the copper we need. Fantastic. Cool. We don't even need to extend it. We don't need copper at all, moltens, going further. So all right, that's what we're going to need. We can slap that in there and move this in here somehow. And let's just do that. Delete this. We don't need that. Okay. I'll copy this again, just so that I'm simulating this input. So this is cool. How far can I get this over? The pipe length extent. All right, hold on. Can I win? I am off by 1. Need slightly longer pipes, but you know what? This is fine. This is a constraint. I will accept this constraint as a thing that I need to just deal with. So, okay, we have something like this. Let me mirror this side just so that we're working off the same thing, and let's think about something else. So, all right, the alternative thing we could do. Got dead min. This is how wide? This is 5. This is 4. And this force place. Yeah, I think we need to do that. It sucks. But all right. If we do this, then we have to go back to the basic recipe again. Let's delete all this stuff. Copy this, flip it, bring that in there. All right. So that nice thing is we could do something like this now. To pick whatever. I'm not going to over micro optimize. I need to figure out the bigger problem right now, which is how do I get this in here? So do something like that. That means I need to bring all this other crap over this way. So something like that. Okay, cool. That lines up. That's good. Where's this? This is not gonna be enough space to get this out and just, all right, whatever. We're gonna work one step at a time here. So I need something like this, and that's gonna kind of come in there. And then we need to think about, okay, so another thing I could do is, I know I'm gonna want here iron, and that extends further. I know that also I'm gonna need copper up here. So if I take the same design and bring this up and bring this out, now we could bring copper in. The problem is I'm gonna need another hookup. So if we did all the way over here and pretended, okay, coincidentally that could fit there, and we could move this up one, and then this can come in here like that. So then we have our molten copper. And then if we do the same design standard here, just to promote some symmetry, we could do iron again, which it's fine having multiple hookups. It's not going to kill us here. Now we have iron, and then this can come in here like this, and then we can remove this extra block. So then that flows all the way through. That's nice. Copper could do the same thing. And then finally here, this is way over the speed that we need. We got to think about like inputs, right? So let's line it up in the direction where these inputs are going to come from. And another thing I need to think about is getting this out. So this is not going to be useful there. So I need like a little bit of space there. So let's just give ourselves a little bit of space. So, and then I got to remind myself that I need to go a little bit over to keep that plastic flowing and keep the plastic flowing. Okay, let's take a step back and look at this whole thing. So conveniently, what we can do now is we could have, all right, we could do something like this and connect. And then this can come down and come in here. So that's pretty decent. Now we need to bring the LDS forward, and I need to, I've already made the conscious decision that I'm going to do this, right? But because I'm going to have them both connected, I would like to bring this up and over. So we could even go something like this and bring this over here like that. That kind of works. Now, layout wise, I'm just thinking ahead. I like that to be there. So we could bring this up and over like that. And then this comes in and can actually just go further. So that's cool. Now, all right, I want on the other lane. The reason I want it on the other side is so that I can actually output this easier. Because like I'd like to do something like, oh, that actually would work. I don't like that necessarily. I'd like to continue the same belt and not create another breakpoint for an extra belt if I don't need it, because that's an extra transport line update time. This is a super minor optimization that I'm trying to do here. So, okay, let me try this. We could remove this. I'll need some more space here in the middle, but it's not terrible. Let's say I do this. So if I have this here, now what I can do is I can flip this around so that it comes on the inside lane like this. And that's actually pretty decent there. Now, it's just not going to be over 60 per second, so we'll need one extra beacon, but whatever. We can add one more up there. So this allows me now to... can I get this out here? We can do this. I think we'll bring this out. This is still not exactly what I want. If I do something like this here, this needs to come in like that. No, that's not going to allow us to side load. Could bring this out, and then we could have this just come forward and then down, and then that would connect. All right, that's not bad. And that gives us actually enough space to do something like this too for sulfuric acid. And just thinking ahead, oh, that is close to being perfect. Hang on. Something like this, and then down merge, right? That's kind of ugly, but you know, that actually solves it. And then we can make it prettier by doing this. We can clean it up later, but that gets us out, right? That gets us to the point where we're loading, bringing it on the belt, we're done. Sulfuric acid then would be here. This can get cleaned up, which is nice. And then we could do this up into here, and then this connects up. And then we're done with sulfuric acid, I think. And I need it up here, and I need to connect this in. So what I can do is if I pretend this is like this, then I just need one sulfuric acid input. Up there, done. Okay, so that brings us all the way around and through. Almost can make this work if I just don't have a way to connect that. Yeah, and then that just passed through. That is kind of an interesting mechanic that you can just pass any fluid through here and it'll work. So, alrighty. So, all right. New problem. We have the issue that I need to get this out. So immediately speaking, I don't have like an easy solution for this because I'm going to need to get sulfuric acid somehow in here. And this is already blocked by this iron input that's on the side. So what I think I'm going to want to do is instead of connecting this here, we can just bring this down. There's no reason that we have to have it lined up there. And then we could do the same thing and just bring this up here, right? So this would come in here like this. This doesn't extend anymore because we don't need that. Let's delete this. Let's delete that, and then delete all the fluids that are currently in here. And then this can come up here. Great. And then this connects now here. So now we have space to run something else. So in this case, I'm going to want up running sulfuric acid for this. And let's disconnect that, delete the fluids that are in there. And let's bring this over here and something like that. That's fine. And then what we can do here now is I need to somehow get this through here. So the easiest thing that I could do is, and I don't like removing beacons if I don't need them, but this convenience of having this here, I think is going to win for me. And then that means I need one more beacon annoyingly here, but it's fine because I also need to think about the fact that I'm going to need to do a very similar thing up on the top to get me some way to pass through because I still need lubricant somewhere. So I need to account for that. So ideally I'd like this kind of keeping the same philosophy because then I can just keep this up here and keep passing through, even though I'm not connecting there, but I could get it through here by doing this and having well, there's nothing stopping me from running it up here, right? So because fluids are fine in the no man's land up here, this is not going to hurt anything, but then I need some space here. Okay, all right, so another thing we can do is we can just bring this over, so this is fine. The reason I'm saying I need this space is because I need to get this out and here, something like this. So this would be the fluids, cool, and then connect that up. And then this can go away. I don't need this. This is the iron inputs. Cool. Everything looks good there. And then I could technically keep that beacon, but again, I'm just going to do symmetry. There's no reason because I have to have these tile on both sides. So I'm going to unnecessarily run this fluid through here, but I don't think that's an issue because again, I'm treating no man's zone correctly. So, all right, let's copy all of this belt routing stuff because I can't fully mirror it because it's not a mirrored design, so to speak. Oh, I have screwed up royally here. I completely forgot this. I need to bring that forward. So this is not going to just work. So that changes things now. We're going to need to run this through here, I think. And not connected there. It needs to pass through. And that's not going to be far enough to get me through there. Ugh, that's a pain. How do we solve for this? If I move this beacon over, can I now bring this down? This is not no man's land, and then this is anyway going to be removed, so we could bring this over. I just, again, can't touch here. And then the green circuits can kind of flow through and keep going, so that's, okay, that's fine. And it just kind of comes through here. So then this can butt up all the way. Yeah, all right, that's fortunately going to have to be the solution. So now, all right, actually that cleans things up. That's just there. Done. All right, I think this isn't screwed up. We are missing copper input, which, okay, that's fine because I just forgot to connect that. So last thing then here, so we got this fluid up, so that keeps going. That's good. Got this connected. All right, let's make the same modifications we made up here. So, oh, okay, and this is because I just forgot it. Yeah, we forgot to add all this stuff in here. Okay, so this is here. This comes over. This is now mirrored. That's good. That's also the same exact layout. That comes over here like this. Let's just clean it up and make it the same thing. Make that go there. Good. And then this comes down here. This comes up here. This is all connected. This is in a good spot. This is all there. And then we need to connect all this up here. So let's copy this, move that in there. Nope. Am I off by one? Am I missing something? No, this is correct. And then, yeah, I'm off by one here. And then this is down here. Yeah, there we go. Okay. So this allows me now to come in here and go over and like that. I'm not going to add extra beacons in here. You could, if you wanted to, if you were like constructing this, you could put like a roboport in there. I don't include robo ports, but you can always just do that yourself later so that you have some build coverage if you're going to build it. So, all right, we'll call it. We'll pretend we were going to do something for that. Okay, no man's zone's fine. This is all connected. This continues on. Mark that. This might work actually just as is. And then this is already on the correct side. This comes out, moves on. Can we cram this in anymore? Not really. I think we just leave this like that. And then, so nicely, this actually is like at a point where we could actually join these two. Let's just test it out. I think we're in a good spot here to just like just try connecting things straight up. And let's see, because I think we did enough correct planning ahead for us. So let's delete all this stuff, delete this stuff and these markers. And let's try to bring this in as close as we can. All right, cool. We got an extra pipe. Who cares? Oh, nope. We are missing steel. I cannot do this yet. Nope. Back up. So something I got to remember is I'm going to have to do this to connect this, do this here, and then I'm going to need steel. So we'll move this over here. Let's get steel inside. And again, we're at 300% productivity, so this is easy. Let's just slam it right up against it, and let's just design in place. There's no reason to make it perfect right off the bat. So this is all nicely connected. That's good. This is going to continue on. Let's bring this up here. And there comes blue circuits. Green is going, flowing. Great. Okay, we should have blue. Nope, we messed up. No, oops. And we move that in there. We move this, delete all this. Try it again. Okay, let's troubleshoot afterwards. We have this coming through, which is going to allow us to connect in here. Yeah, so we can just keep going, bring it over. So this is steel now. So we're going to need green circuits to come through somehow. I don't know. We'll just route it up here. Simple. And then, I don't know. Do we want more beacons somewhere? Not really. I don't think we need it. Like, I don't think we need to even add a beacon in here. There's no reason to. So we might as well just go like this. And then that convenient can go on the outside lanes. Oh, all right. That's crazy convenient. And then over. And then how far over do we want to go? Yeah, just slam it up like that. Cool. I don't know. Just slap it somewhere. Let's have those mirrored so that this is all symmetry aligned. Cool. All right. And then conveniently we can bring this out, and then this just needs to somehow come in and over. Doesn't really matter. No reason in overthinking that. Nice. Everything's connected. Do I need more speed on this? No, 153 is plenty speed. So we got batteries coming through. Got this. Hang on. We might actually have a build. Now, I haven't kept at all attention to the time. So editor me is going to have to go and tell me how much time I've taken so far. But let's first make sure that this actually works. So let's just copy the whole thing, paste it somewhere so we can go look at it. And let's just run it. So we have the occasional flickering going on because we're running out of blue circuits. Let's just trim these first off. We're not getting enough blue. Why is that? And it might just be that it needs to buffer for a little bit, but like, let's let it back up. Let's run it for a little bit. Let's let it back up completely. And let's just go run it and see if this actually just recovers. And I may go and open up a clean editor save file that has nothing else in it. Let's just go do that. Let's copy this whole thing. And then I'll put it, the template maybe, put that in here. Ignore these other designs in here. These were failed baseline attempts. All right. Save clock experiments. Load the base here. Let's load that up. Power. Global electric network. We're good. And bring this bad boy in here and run it at 64x speed. And let's just see if we're ever going to be underproducing. That's pretty decent speed wise. Let's just go 96. Let's override that. Let's go as fast as we possibly can. And let's just look at production line stuff here. This is perfectly fine. Blue circuits aren't dipping. This is cranked to the max. So this is 30,000 a minute. Yeah. This is starting to flicker occasionally. And what is it? It's blue circuits again. And it's occasionally running out of electronic circuits. I bet this is because of the way stack inserters work and priorities and dropping onto the belt that is just not able to keep up. This is just really weird. Like, we have enough capacity here. This is running 24/7. And I bet this is just like occasionally not able to drop. It's really, really weird. It may be because it's just too fast. I wonder if that actually helps things out by just actually purposefully slowing this down to make it more consistent. There's still gaps occasionally. You know what? We are going to go and change this completely out here. Let's just go ahead and pause this. I could add one more beacon in here to try to get some extra speed on there and get more productivity, but then I'm not gonna be able to keep this belting, so I'm just gonna call it a day and just put an extra speed beacon in here. I just don't care. That's fine. Let's see if this actually can now just recover on its own. So there's some gaps. Delete this and let everything build up. Monitor for gaps there. There are 0 gaps forming. And let's just watch blue circuits. If this ever starts forming gaps at this point, then we're going to have some issues. Look at processing units here, production. We're hovering at 47 per minute, 4,800 per minute. Do I have all the correct technologies researched here? Quick check. Yes, I do. LDS as well. Okay, we're good. Yeah, we're getting slight little gaps. This is fully backed up. This is consuming correctly. This is now producing 262 per second. Is this not producing fast enough? Has it been iron this whole time? No. Yeah, if you do this, then it just runs perfectly fine the whole time here. Let's move this up. Let's just see if that just fixes everything by just having this go a little bit faster. This is the troubleshooting that's like a little bit interesting. I do the Edison approach and just kind of do a vibes-based thing. Ideally, this is overproducing blue circuits, so this should then back up occasionally. But this is now seems stable looking at this. And if we look at processing units, now we're over. Yeah, that fixes processing units. Let's see if we bring this in now here. If that sees any drop. Yeah, that drops it. So we're somehow choked on electronic circuits. And it overproduces, so it shouldn't matter. Like, this should still be stable, but if we can't... Yeah. All right. Well, I can't explain why. Probably someone in the comments can explain it better than me, but that seems to be enough to just have it back pressured, and it'll be good enough. This seems good. Let's go make sure that it can tile, and let's delete the no man's land stuff that I don't need anymore in here, along with any other constant combinators that are no longer needed. That all looks good. Let's copy this, do this test here. If I just paste this in here now, do I get another full output lane? And we're missing something for sure. Oh, cool. So that needs to stack like that. There we go. That looks good. Let's undo this. Undo this. Let's go back to normal speed. And then we'll just have this so that it can tile. Good. Excellent. Let's mark this. These are going to be all the inputs that we're going to need. Let's have that there. Yep, that's good. So now we just need to finally just worry about power, which is the easiest thing in the world to do. Just go and add this. Bring this in here, grab these in, even stretch this a little bit further. Oh yeah, we could totally just do the delete that. We can have the least number of power. I always save power for the end because it's the easiest thing to do. You can just kind of think about it. Unless you have a super compact direct insertion build, it just doesn't matter. So, okay, so like in this case, yeah, we can bring this in here, bring this in here. Now we got enough power. Bring this even further over. Have power there, power there. Now, this is where it gets a little crammed. We could probably move this over too. And then just further bring another power block up there. And then that kind of gets gross. All right, so that doesn't work for symmetry. So I'm a fiend for symmetry. Just, I am who I am. So if... I mean, we could just do this. It's not amazing, but it works for what we need. Little quick check what it looks like on the map. That's great. And then I think we've got power everywhere. I'll hold this. Yeah, it seems like it. So here's the check. We can delete this and just bring in the power to the location here and turn off global electric network. This way we can check that everything's still powered, which it is. And then this is also a good kind of test just to make sure that we haven't lost anything. Art here. Yeah, blue circuits are actually keeping up now. Yeah, everything looks good. Cool. All right, so that's the baseline build. If I was actually doing this for UPS, things that I'd like to change is I would 100% want to optimize this to be directly inserted. The reason being because you can create probably a pretty decent layout with something like this, which I'll actually go and showcase instead. So let me copy this. This is going to be the baseline build, and I'll go, got that, edit, good. And we'll go create that blueprint, and we'll put that in there. Good. That'll be the baseline. The fluids, well, I'll talk through here in a second. Let's just load over here. Let's go to editor type stuff. Go and load up clock experiments again. Here are some of the previously like failed designs. So we got close with like a similar kind of concept, but it just didn't work. I ran out of time for blue circuits, another blue circuit concept. We had, this was the direct insertion layout that I'm talking about. I think for UPS, this is going to be just ideal. You do have to route the copper and the iron, but you can kind of see this was a general idea that I had was I wanted to route more like having this standard kind of bus philosophy of having the fluids all in the same location, which I tried to do and kind of failed. Ultimately, what we landed on, we eliminated some beacons with the final design here, but so that's a good thing. But more so, I tried this general concept here and did some cursed Michael Hendricks style belt weaving here. So I really like this design, and this actually perfectly lines up with the build that we just did. So we can grab that baseline. We could very easily say this is going to be better and swap this whole thing out. It doesn't take up much more space and would actually do what we want. The only thing that it doesn't solve for is it doesn't solve for engines, and you need to belt engines in. But I think ultimately belting in engines, when if you look at the ingredients, the electric engine units themselves are so incredibly small in terms of the consumption. Actually, that's not true. We could just take the same thing and just copy it in. Never mind. The benefit here is that this is the highest input is the electronic circuits. So it made sense to me to say like, hey, we direct insert that. So in like priority, whatever I can is the highest of the inputs for a thing that I'm going to make. I'm going to try to direct insert it, especially if all the byproduct inputs are all going to be fluids. That's kind of my general philosophy, and this actually worked out pretty good for this design. And then I just ran out of time and just completely screwed up my blue circuit. So you can kind of see just based on the time that it took to actually get the blue circuit design finalized, that is usually the bigger timeline that it takes. So anyway, let me walk you through my actual build that I'm going to be submitting for the competition. So this is my cursed fluid setup, which is what I'm going to use for the baseline as well. It's not really cursed, but what I'm doing here is I want a crap ton of, and how do I get that? Well, I'm gonna need a lot of heavy oil. Well, what makes the most heavy oil? Coal liquefaction. It makes the most. It makes a little bit of light oil, which I can just crack back down immediately into heavy. So that's super easy to do, or back into petroleum, which is actually what I want, what I need. So here, really simply put, we have a bunch of regular raw basic oil processing here. And then the only real inputs that we're dealing with is we still have these other two, but yellow is immediately going to get cracked into petroleum gas. So we have some water that comes in here, but we just have then very simply, we have enough here to create the petroleum gas that we're going to need. So if you look at this, here's your basic oil processing. This is going to create well enough of the actual petroleum gas that we need. And then all it does is it just checks like, hey, do we need petroleum? And this is just very simply detected here. So whenever this falls below 18,000, we're going to go and say we need more petroleum gas. And it will naturally act as a latch and go and produce then petroleum, because the pressure is going to drop, and then it takes a while to kind of build that back up. So, and then simply here, what I'm doing is I'm just heating up a heating tower constantly. And then if the temperature drops below 600, we're going to go and run. And this is a latching condition. If coal runs out, or in the case, and coal and the temperature is less than 600, we're going to go and insert the, we're going to turn this mining drill on just to put some extra coal in there. So if the temperature right now is stably above it, even if we drop below the coal amount here, we're going to wait until this temperature goes below 600, and then we'll turn it on again. That way, if we get to a situation where we no longer need steam in these, in the heat exchangers here, and we're not producing steam anymore, then this whole build will kind of just shut down on its own, which is good. And then sulfuric acid, it's super easy just to produce. That is a very basic thing. Same kind of concept then here, just latching stuff, just making sure that you have enough of the heavy oil so that you never run out to continue to see the coal liquefaction. The only downside is you need to kickstart this with a little bit of heavy oil, but that's not a big deal. This is going to be the submission that I'm making, and then this is my actual design that I have. So for the standards of the competition, you're going to have to create a template that's going to make 12 lanes of utility science. And this one I spent significantly longer than the length of this video going and creating, right? So I spent probably about, rough estimate is about 14 hours, just like going back and forth, trying different things, thinking. You see here, I'm making actually per design 2 lanes of utility science. And that's because of just how nice and convenient the ratios are to go and create 10 per second electronic engine units here, and then you can create a really nice little direct insertion build. Of course, everything here is also clocked, which we didn't even touch in this design. And I'm going to leave out of scope since this is something that you can slap together in about an hour is what I gave myself timeline with. So this is where all the coal is going to come in. This is my setup for producing blue circuits, which is actually leveraging direct insertion for plastic here, and actually bring then the coal further down the line so that I can go and use it for producing LDS in line here. So I'm actually directly inserting LDS into all these locations with more direct insertion of plastic bars. So we're not belting anything here pretty much. So everything as much as possible is directly inserted. And you can see that with the minimum number of wake lists that are here, right? Just that are activating, deactivating. So most stuff is pretty nicely clocked here for this. So this is the actual design that I'm going to be using in the competition. And I'm actually really looking forward to seeing everyone else's designs. So we'll see those here in the future as well. And I'll close this off by showing you what the template save file looks like. Here we go. Here's the template save file. You can see, this is what all the designers are going to see already, the blocks for the input ingredients, and we're going to just pretend that we're belting in calcite. So if you don't need this amount of molten liquids, you can change it, and anyone could change it. But the main thing is that you can see here, I just have this design, so if somebody wants to just copy it, they can use it, and they don't have to think about it. If they've incorporated into their design, great, they can use it. They could also change it. Maybe they want to test out something different, see if that's better. So very minimal sizes of coal, so very, very small coal patch is going to easily fit here to get this to work along with this. So you don't need a huge coal patch to make all that work. And then finally here's that exact same design. So all the designers are actually going to be able to immediately test if their stuff's better than mine. So if they want to run benchmarks themselves, I have no problem losing. I actually would much rather prefer someone beats me. So that's why I'm just going to give, here's my submission exactly as is, and you can go and use it for comparing against the template that I've listed out for all the other designers that can compete in this. So yeah, then that's all hooked up. Main thing that I'm looking for is what I wanted to show was that I'm looking for an hour-long stable production. You can see here, this is exactly 172,800. And the production output, that's going to be, if you divide that by 60, that's 2880 per second. So that's the target. So someone might go and create half this production rate, and they might be making uncommon science, for example. In the end, what I'm going to do is I'm going to use Region Cloner. I'm going to go and highlight everything that's in here. And then I'm going to go and copy this as many times as I need to hit until this starts to drop below a certain speed. So let's say we do 64x speed here, just so we can see something kind of coming up on the numbers. And then let me go and copy to the north. I don't know. Let's say 16, 15 copies, because it includes the first one. So I'll go and do that, 15 copies to the north. And then you can see the UPS has dropped down to about 600 UPS, which is pretty decent. And then you can just kind of see that, all right, the production graph is at 2.8 million. That's a good amount of load. Looking at pressing F5 here, you'll see the update time is in the 2 millisecond range. It's pretty good for us just testing things out. This is going to be how I'm going to go and set things up. So that's the next phase of it. So in this competition, the next steps are going to be, I will compare, this is going to be my actual design that I'm going to be using that is my entry, so everyone has access to that. And then the next thing is going to be taking that baseline, going and creating also a template save file like this, so that, and using the template to go and introduce the baseline that we just built. And then I think I'm going to include my current utility science, which is currently in my base. So the utility science design that I'm talking about is this guy here. This is my current design that goes and produces the amount of science I need. I think it's stable as long as I don't have weird back pressure like I have here. So see a really similar kind of layout that does 10 beacon design, and then ultimately down here there's a lot more curse stuff going on. So that's why I don't think it was going to perform well, but and I'm belting a whole bunch of intermediary materials, and I'm sure someone has created a much nicer Q2 design. But so we'll just see what this one looks like as well. So it'll be a fun competition. I'm very excited for it. Again, deadline is going to be this upcoming, this upcoming weekend. So more details are on my Discord, along with just the announcements that are in there. And that's actually how you have to submit. You got to be part of the Discord to go and contribute. So we'll see you hopefully in 2 weeks with some initial results from the utility science competition. And I look forward to seeing you then. If you made it this far in the video, thank you for your attention span. Thank you for you sitting around and listening to me talk for as long as I did. If you like this sort of long form content, let me know in the video description below. This is a much more verbose style design tutorial than I normally would go and release. So if you like this kind of length of content and this kind of just in-depth design with me style, I can do this more often. Just let me know. Otherwise, if you like this channel and you want to support it, subscribing is huge. And also just even liking the video goes a long way. So other than that, thank you so much for watching. My name is Abuck Nasty. Have a fantastic rest of your day.